The topic of electric fields investigates an effect that everyone is familiar with, electric repulsion and attraction, and it formalizes it into a physical theory. Our investigation started with placing a charge Q1 in space, and notice that I haven't said whether it's positive or negative. And we investigated what the electric force would be between it and a positive unit charge that we placed in the surrounding space at a distance r. We found that the expression for this force was as follows, and that it points in the r hat direction, which is away from the other charge. Since this is the force on a unit charge, we call it the electric field E around the charge Q1. And it has units of newtons per coulomb, force per unit charge. Notice now that if we set Q1 to positive, this force points in the positive r hat direction, i.e. the unit charges will be repulsed. But if Q1 was negative, it would point in the negative r hat direction, i.e. the unit charge will be attracted. We then considered the energy changes when the unit charge travelled from an infinite distance from Q1 to a distance r from it. We call infinite distance the zero energy reference point, so any change in energy from this point we can just call the new energy. Again, we are looking at a unit charge, so we call this energy the voltage, and it is given by this expression. The units are joules per coulomb, energy per unit charge. Notice now that if Q1 is positive, the voltage will be positive, since we would have had to push it against the electric repulsion to move it closer, doing work on it in the process. If Q1 was negative, the voltage would be negative, since that zero energy at an infinite distance would have been transferred to kinetic energy as it flew in closer. With these two definitions, we can easily expand our discussion to an arbitrary charge Q2 rather than the unit charge. To work out the electric force between Q1 and Q2, we simply multiply the electric field by Q2, and this now has units of newtons. And to see the potential energy of Q2, we just simply multiply the voltage by the charge Q2, and this now has units of joules. It is clear that we can link the force and energy equations simply by multiplying or dividing by r. But I must point out here that this is somewhat a coincidence, and I haven't derived why that is the case here. We also looked at field lines as a way of drawing electric fields, and saw that if we had two oppositely charged plates with a potential difference V across them, at a distance d apart, that the electric field between them would point from the positive to the negative plate and would have a field strength of V over d.